we want to prove that 4 to the power of n plus 5 to the power of n plus 6 to the power of n is divisible by 15, and also if n is odd. So there's two things here. First of all, we've never worked with three indices, as you can see here, and it's also odd. So remember how we did the even questions before? We were increasing more than one. So the same thing applies here for odd. We want to be increasing more than one as well. Okay, so step one is to always show it's true for n, for the first n value. Now, n can't be 0 here because we want an odd number, and 1 is your smallest odd number. So substituting 1 in, we get 4 plus 5, which is 9, plus 6, which equals 15, which is indeed divisible by 15. And therefore it is true for n equals to 1. Now, in step 2, we want to assume that this is true for n equals to k. So we substitute in k, and we make it equal to 15m, yeah? Because it's divisible by 15, we want it to be able to be multiplied by 15. Now we have to add where k is an odd integer, because if n is odd and n equals to k, therefore k must be odd as well. And it's important that we do specify this in our proof, because otherwise it throws off this assumption. So the assumption must hold true for all the information up here. All right, now, step 3. So in step 3, let's show this is true for n equals to k plus 2. So remember how I said we're going to be increasing by more than 1 here? Because to make sure that this is odd, I have to go, well, start off with 1 plus 2 to be 3 plus 2 to be 5. That's the only way I can ensure it's odd. So that's why I have n equals to k plus 2. Alright, so by substituting in k plus 2, I have 4 to the power of k plus 2, 5 to the power of k plus 2, 6 to the power of k plus 2. And I want to show that it's divisible by 15, which means that at the end of this, I want to be able to factorize out 15, right? That's the way we show that's divisible, is if we can factorize our number out the front. So to show that this is divisible by 15, first thing I want to do is manipulate that. And what I've done here is I've just separated all the k plus 2 into to the power of 2 and to the power of k. So for 4, 5 and 6, this is what I've done. And now I want us to consider the assumption. So there's always somehow we've got to work the assumption in there, isn't it? Now, we assumed in step 2 that 4 to the power of k, 5 to the power of k plus 6 to the power of k equals to 15m. Now, I don't mind which one you choose, but we do have to substitute this into here somehow. So we've just chosen 4 to the power of k for simplicity's sakes. So I've just subtracted 5 to the power of k and 6 to the power of k over to this side, and substituted this into here for the 4 to the power of k, yeah? Because here I've said 4 to the power of k equals to this, so I've substituted that in. Now, we just need to expand that. So it's just a simple matter of expanding that factor. So 16 times 15 gives us 240. This is just 16 times negative 5, 16 times negative 6, and this stays the same. Now, what can I do here? So remember, I want to make it divisible by 15, so I want to be able to factorize out 15. So I need to simplify first, because right now it's just looking, it's 2 everywhere. What can I do here? Yes, that's right. I put together the common factors. So this and this is common, so I can just add that together. And now this and this is also common, right? So what I've done is just added them together. 25 subtract 16 gives me 9. 36 subtract 16 gives me 20. Yeah? Okay, I have 240, which I can take out 15 for. 9 and 20, I can't take out 15 for either of those. So what am I going to do here? How can I change this in any way possible? Well, the only thing you can actually do is by taking a 5 out of there, isn't it? And what I mean by that is you can make that 5k equal to 5 times 5 to the power of k minus 1. So I'm taking this 5 out of there. So if I do that, then I can multiply that and hope we can divide it by 15. So I've just taken the 6 out of there as well, right, in the same way. And by multiplying them together, this gives me 45 and this gives me 120. So you can see that yes, we can take out the 15. Now sometimes if you can't take out 15 yet, you have to take out another 5 and then see if that can be divisible by 15, right? All right, so what we need to do is check that this is going to be an integer. Now because, even though it's -1, we know -1's a fraction, because the smallest value that k can be is 1, that means the smallest value that whole thing can be is 0. So that means that this will still just be 3 times 1 plus 8 times 1. So this would definitely be an integer. So we can say, therefore, this is divisible by 15. So therefore it is true for n equals to k plus 2, remember? And in conclusion, thus it is true for all odd numbers for this equation up there.